Natural language processing, or NLP, is the field of artificial intelligence that focuses on enabling computers to understand, interpret, and generate human language. It sits at the intersection of computer science, linguistics, and machine learning, and it is one of the most transformative technologies shaping the modern world. From voice assistants like Siri and Alexa to real-time translation tools, sentiment analysis, chatbots, and search engines, NLP is embedded in many of the applications we use daily. At its core, NLP is about teaching machines to make sense of language in all its complexity. Unlike structured data, such as numbers or dates, human language is messy. It's filled with ambiguity, nuance, context, emotion, and cultural subtleties. A single phrase can have multiple meanings depending on tone, order, or even punctuation. Consider the sentence, "I saw the man with the telescope." Who has the telescope? The speaker or the man? Humans use context and common sense to resolve such ambiguities. The early days of NLP relied heavily on rule-based systems. Linguists and computer scientists manually created grammatical structures, word lists, and parsing rules. These systems worked reasonably well for narrow tasks, but were brittle and difficult to scale. They could not adapt easily to new languages, idioms, or slang. As language evolved, the systems had to be constantly updated. The advent of machine learning changed the landscape. Instead of writing rules, researchers began training algorithms on large corpora of text. These models learn statistical patterns, such as which words tend to appear together or which sequences likely indicate a question. Algorithms like naive Bayes, hidden Markov models, and later support vector machines allowed for more flexible and scalable approaches. They powered early spam filters, part of speech taggers, and document classifiers. But the real revolution came with the rise of deep learning and neural networks. Current neural networks, RNNs, long, short-term memory, LSTM, models, and later transformer architectures reshaped NLP entirely. These models could capture dependencies across long text spans and learn nuanced representations of words and sentences. Instead of treating each word as an isolated symbol, models began to encode words as vectors in high-dimensional space, allowing them to understand context, similarity, and even the transformer architecture, introduced in the landmark paper "Attention is All You Need," marked a turning point. By using self-attention mechanisms, transformers could process entire sequences in parallel and dynamically focus on relevant parts of input text. This innovation led to models like BERT, GPT, and T5, each pushing the boundaries of what machines could do with language. BERT, developed by Google, allowed models to understand context bidirectionally, considering both the left and right words in a sentence. GPT, developed by OpenAI, focused on generative capabilities, completing prompts, writing coherent paragraphs, and even producing creative content. These models were trained on vast datasets, learning grammar, world knowledge, and patterns of reasoning from billions of words. However, these breakthroughs did not come without challenges. Large language models require immense computational resources and energy. They raise concerns about bias, misinformation, and ethical use. If trained on biased or toxic data, the models can replicate and amplify harmful language. The question of how to make NLP both powerful and responsible is one of the field's most urgent debates. Another complexity is language diversity. Most state-of-the-art NLP models are trained predominantly on English. Low-resource languages often receive little representation, which risks creating digital inequality. Efforts are underway to develop multilingual models and tools for underrepresented languages, but the gap remains significant. Despite these challenges, NLP continues to evolve rapidly. With fine-tuning techniques, pre-trained models can be adapted to specific tasks with minimal data. Transfer learning has become standard practice, allowing developers to build high-performing NLP systems without training from scratch. This has democratized access to NLP tools and accelerated innovation in industries from healthcare to finance to education. NLP also plays a crucial role in bridging the communication gap between humans and machines. One major application is conversational AI, systems designed to carry out natural flowing conversations with users. These include virtual assistants, customer service bots, and interactive teaching tools. The challenge here isn't just understanding words, but intent. What does the user actually mean? Are they asking a question, making a request, or expressing emotion? Intent recognition, entity extraction, dialogue management, these are key components of modern NLP systems used in conversation. With reinforcement learning and large dialogue datasets, systems have become increasingly adept at maintaining coherent exchanges, adjusting tone, and remembering context across turns. Another impactful application is sentiment analysis, the ability to determine whether a piece of text expresses positive, negative, or neutral sentiment. Businesses use it to monitor brand perception. Governments use it to assess public opinion. Mental health platforms use it to track user well-being. Sentiment analysis, however, is notoriously tricky. Sarcasm, cultural expressions, and subtle emotional cues can fool even the best models. Machine translation is another pillar of NLP. Tools like Google Translate or DeepL have improved dramatically with neural machine translation. Instead of word-for-word substitution, these models learn how meaning maps across languages. They handle grammar, idioms, and word order with surprising fluency. Though they still stumble on low-resource languages and specialized domains. Text summarization, question answering, keyword extraction, topic modeling, all fall under the NLP umbrella. In journalism, NLP helps sift through massive documents and pull out key facts. In law, it enables rapid contract analysis. In medicine, it turns clinical notes into structured data. The range of applications is vast and growing. And with the arrival of instruction-tuned models, NLP is entering a new era of alignment. Instead of just predicting the next word, models like GPT-4 are trained to follow human instructions, answer questions truthfully, and stay within guardrails. This alignment process, often involving human feedback loops, is critical for safe deployment. It moves NLP closer to tools that serve human goals with transparency and reliability. Looking ahead, the future of NLP may involve deeper integration with other modalities. Multimodal AI combines language with vision, audio, and even action. Imagine systems that not only read text, but also see images, hear voice tone, and respond with empathy. This cross-modal understanding will enable richer interactions and more capable assistance. We may also see more emphasis on personalization. NLP systems that adapt to your communication style, learn your preferences, and speak in ways that resonate with you. This personalization must be done carefully, with respect for privacy and consent. But the potential for more human-like connection is immense. Ultimately, understanding natural language processing is about understanding one of the most profound interfaces between humans and machines. Language is how we share knowledge, express emotions, form relationships, and shape the world around us. For machines to truly serve humanity, they must grasp this complexity, not just syntactically, but semantically and emotionally. NLP is not just about algorithms. It's about empathy. It's about building bridges across cultures, reducing friction in communication, and empowering people with tools that listen, learn, and understand. As NLP continues to evolve, the responsibility grows. We must ensure that the language machines learn reflects our highest values: diversity, clarity, and respect. Because the words they generate shape how we interact, how we make decisions, and how we define truth in the digital age. The better we understand NLP, the more intentional we can be in guiding its development, not just toward intelligence, but toward wisdom. In a world increasingly mediated by algorithms, the ability for machines to understand language is not just technical progress. It is a reflection of how well we understand ourselves. NLP stands as one of the most powerful frontiers in AI, where every breakthrough brings us closer to truly meaningful human-machine interaction. So as we continue to build, train, and deploy these language models, let us do so with clarity, with purpose, and above all, with the human voice in mind. That voice is not always logical, it's not always neat, but it is always powerful, and it deserves to be heard with care, with nuance, and with understanding.